All right, hey, let's do part 2 of the review, the quiz review for Monday. I got way too sleepy last night to keep recording, so starting over today. That'll do. All right, so the first video you guys watched was just about the Pythagorean theorem stuff, and now we're moving on to the trigonometry stuff. So SOHCAHTOA starts now. Let me get these calculators out of the way. So looking at this first problem, you're not really making calculations yet. You're just giving the value of sine, cosine, tangent as a fraction. So for something like this, if you wanted the sine of Q, you would find angle Q. It's that angle there. You'd label your opposite side, which of course is the one across from Q. You'd label your hypotenuse, which unfortunately we are missing. And so we're going to need to find that. And we have the adjacent side. So right now, any trig function that involves the hypotenuse, we're not going to be able to find it yet because that side is missing. But we could do the tangent right now, because tangent is opposite over adjacent. So we know that our tangent will be 30 over 16. But don't forget that every fraction you give me has to be reduced. And since 30 and 16 are both divisible by 2, you have to divide by 2 and give me your answer as 15 over 8. Now, sine is opposite over hypotenuse. Again, how do I know this? It all comes from SOHCAHTOA, right? So you've got SOH, that's telling you that sine equals opposite over hypotenuse, okay? Then you've got CAH and TOA. So that's a quick way to memorize which trig function uses which sides. Now for sine, it's opposite over hypotenuse, like I said, so it's 30 divided by whatever the hypotenuse is, but we don't know what it is yet. So when I said that we were moving on from the Pythagorean theorem, I guess I was only kidding, because we do have to use Pythagorean theorem one more time to figure out that missing side. So, alright, a squared plus b squared equals c squared. We know that c has to be the hypotenuse, and since the hypotenuse is what we don't know, we'll use our variable there. We'll say x. And a and b are the legs, 16 and 30. So we'll go 16 squared, 30 squared. Now 16 squared is 256, and 30 squared is 900, and that's going to give us x squared. So adding those up, you get 1156, which equals x squared. And then you take the square root of both sides. And so you get an answer of x equals root 1156. And I think that comes out cleanly, right? You should always check. If you leave your answer as a radical, then it might not be simplified all the way, so you should at least check. Now, how do I turn this calculator on? Okay, there it is. So let's type in 1156, and then to get the square root, you hit the button that looks like a radical, and we see that it does come out exactly to 34. No decimal places or any of that. So let me turn this calculator back off, and we'll take our 34 and move on. So x is exactly 34, which means I can now use that in all of my trig expressions. So that means sine is going to be 30 over 34, but again, do not forget that you must reduce. If you chop those both in half, you get 15 over 17, and that's the only acceptable answer, is that reduced one. One more time, if you have a TI graphing calculator, let me pull that up. Here it is. Let me just move it over. Actually, let's leave it over there. Okay. Just know that your TI calculator can actually reduce fractions for you. So if I clear this screen out, if you had the 30 over 34, but you didn't know how to reduce that, then you could type in 30 over 34, go ahead and click enter, and make it into a decimal. Then the way that you have the calculator simplify that for you is here in the math menu. See my cursor circling around the math button? Press that, and you get this whole mess of options. And the one you want is the very first one, so it's very easy to find. It's at the top of the list. But that little arrow means convert to fraction. So if you just press enter, then it's going to take your previous answer, the decimal, convert it to a fraction, and that fraction will always be in simplest form. So it won't just give you back 30 over 34, it'll give you back, boop, 15 over 17. So it reduces it for you, and this works for no matter what you type in. If I did 240 divided by 366 or something, I'm just making it up, but you can simplify that. Boop, it goes down to 40 over 61, and you know that 40 over 61 is the simplest form, and so you can always give me that as your answer, and rest assured that that's the best possible answer. Okay, so moving on. What would be the cosine of Q? Well, cosine is adjacent over hypotenuse, and since 16 is adjacent, you'll get 16 over 34. But the final simplified answer is 8 over 17. Alright, and from here what I hope a lot of people remember is that if we switched over now to angle R, then the side that used to be adjacent is now opposite. The side that used to be opposite is now adjacent. And that means that the sine and the cosine switch. So if cosine of Q was 8 over 17, you know that the sine of R is going to be 8 over 17. And if sine of Q was 15 over 17, then cosine will now be 15 over 17. And what happens to tangent is you get the reciprocal. So instead of 15 over 8, you get 8 over 15. But you can find those values pretty quickly if you remember that rule. Okay, so let's move on. So now in these next few problems, these are a different kind of trigonometry problem. This time we're going to actually set up equations and solve them. So I'm going to need this calculator. Let me move it over. Okay, and for number 7, let's talk. For number 7, you would certainly first focus on the angle that they gave you. It's 54. You look at what sides you're working with, and we're working with opposite, and we want to work with adjacent. And what we want to do is ignore the hypotenuse. So our next step is to set up an equation, and that equation will always be either sine, cosine, or tangent of the angle equals the fraction side over side. So it sounds like we need to figure out whether we want sine or cosine or tangent. And what I do is pretty much every time, you just literally write out SOHCAHTOA. And again, your two choices here are, well, if you know that you can't use hypotenuse, then cross out anything that has h in it. I can't use sine and I can't use cosine because I don't have a hypotenuse. So you know that you must write a tangent equation, right? The other way that you know that is, well, look at what you do have. You have O and A. So of these three options, where's the O, where's the A? Aha, it's right here. So I know I need tangent. So you can kind of do process of elimination by scratching out whatever side you don't have, or you can just find it directly by thinking about what sides you do have and matching that up with the right trigonometric function. So anyway, hopefully we agree that we want a tangent equation, and we know that we want the tangent of the angle. The only angle we have is 54. Then we know that tangent is always opposite over adjacent. So the side that we want in the numerator has to be the opposite side. That's the variable x. The denominator should be the adjacent side, so the 9 goes downstairs. Now my advice to you for solving this was, you can always just put tangent over 1 to make it a fraction equals a fraction, and then you cross multiply. So we do the 1 times the x, and that gives us x. Then we do the tangent of 54 times 9, and that gives us 9 times the tangent of 54. So after cross multiplying, we're here. We have x equals 9 times tangent of 54. And honestly, you could kind of stop here and just give your answer as 9 times tan 54. That's the exact answer. But I would like you to actually go down to a decimal to try to figure this out. So you've got two choices. Again, if you don't have the best calculator, then we would have to hop over to our trig table and find the tangent of 54. So on your trig table, you got to find 54. I might need to turn this calculator off. So 54, where's that? Well, this is only 0 through 30. Here's 30 to 60, so 54 must be right here. And we want the tangent. So make sure you're in the tangent column over here, and we can see the tangent of 54 is 1.3764. 1.3764. So we want to do 9 times 1.3764. And now, even if our calculator doesn't do tangents, Well, our calculator definitely does 9 times this decimal, so you may just have to type it in. So let me pull up the stinky calculator just to show you that if you use the table of values, then you're going to be fine. You can still get your answer. You just do 9 times 1.3764. And I'm getting an answer of 12.39 because the 7 rounds us up. So 12.39. And that would work. And you'll notice that my calculator does have a tangent button on it, so we could have tried that. Now, to do it though, you'd have to do the tangent of 54 first. And the keystrokes are a little weird. You'd go 54, then you'd get the tangent of that as a decimal. Then you'd say times 9, then you'd say equals. We're getting the same answer. And of course, the easiest thing in the world is if you have the other graphing calculator. This one. Then you could type the whole expression in pretty easily. You would literally just type in 9 times tan 54, press enter, and you get your answer right away. The same 12.39. So no matter what calculator you have, you should still be able to come up with a decent answer. And then just throw a box around that answer and move on to the next problem. Okay? So speaking of the next problem, let's head over to number 8. Shoop. And in number 8, we're going to do the exact same approach. That approach being find the angle you've got and label the parts. We've got opposite and we've got hypotenuse. Since we have opposite and hypotenuse, we know that we need sine. That again is just coming from SOHCAHTOA. So this time my equation should be the sine of 46 equals 24 over x. Now this should feel different because in the example we just did a minute ago, our variable was in the numerator, right? See this one over here? Our variable x was upstairs in the fraction. So we cross multiplied, we got x equals 9 tan 54, and from there we could solve pretty directly. This one's going to be a little different because this time when you put this over 1 and cross multiply, well 1 times 24 gives 24. But then you get x times the sine of 46. And you can see that in this equation, x is not alone. And the whole point of algebra, the whole point of solving equations is to get x alone. So the way that you would get x alone is you'd have to get this sine 46 to cancel. And a few people that I worked with would say, hey, okay, why don't we subtract this? But you can't subtract that from both sides because this is connected to x by multiplication. And the opposite of multiplying is dividing. So you certainly want to divide both sides by the sine of 46. And what happens is the same thing that always happens when you divide a number by itself. They cancel each other out. And so that means that this right-hand side now is just plain old x. And our numerator over here is 24. We're dividing by the sine of 46. And so we can figure out what this is by doing 24 divided by whatever the sine of 46 is. And again, if you don't have the right calculator, then boom, you'll have to go to your sine chart. And my sine chart seems just a little too big. That'll work, I guess. We want the sine of 46. I think that's what I said. So 46 would be right here. I want the sine of it, so make sure you're in the right column. But I'm getting 0.7193. So the sine of 46 is just 0.7193. And then from here, no matter what calculator I have, I can do this division problem. So let's pull up a calculator and do it. Here you go. So in this calculator, I'm just going to type 24 divided by 0.7193 equals, I'm getting 33.37, 33.37, and that's it. So that's two different problems. In the first problem, we had x in the numerator, and so the algebra worked a certain way. In this problem, we had x in our denominator, that made the problem work a slightly different way. So let me move that calculator out of the way. But again, you saw that the initial setup for these problems was slightly different. In the first one, x on top. Second one, x on the bottom. So when x was on top, we ended up just multiplying 9 by tangent. But when x was on the bottom, we ended up finding x by doing a number divided by sine of 46. That's kind of the difference. It'll always end up like that. Let's do more examples and you'll see what I'm talking about. Alright, again I assume I'll need this calculator, so I'll just move it over there. We can focus on number 9. I'm going to start going a little faster, of course, because we already did the 2 examples, so if I go a little faster you'll probably still be okay. Drag this line out of my way. Alright, so for number 9, again, mark the angle that you're really using. We're using this acute angle up top. That means the 13 down here is opposite. That means the x over here is adjacent. Since I'm working with opposite and adjacent, SOHCAHTOA, TOA says we want to do a tangent equation. We'll do the tangent of 27. We'll set it equal to 13 over x. And so again, to solve, if I put this over 1, then I'm going to get 1 times 13 is 13. It's going to equal x times the tangent of 27. And that means to solve for x, I'm again dividing. So I'm going to end up with 13 divided by tangent of 27. And it's going to equal x. Okay? So can I do this on my little stinker calculator? Let's see. Excuse me, apparently I'm tired again. Alright, so how can I do this? I think if I say 13 divided by 27 and then take the tangent of it real quick, then it's going to do 13 divided by this number. I hit equals. Yeah, that feels right. So 25.51 should be the right answer. So that's x for number 9, and then we can move on to 10. Move my calculator. So for number 10, I'm working with this guy. There is no opposite this time, but there is an adjacent, and there is a hypotenuse. So if I'm working with the that sounds like ka, so SOHCAHTOA. This is a cosine problem. And we're going to do the cosine of 35. Set it equal to adjacent over hypotenuse, so x over 21. So we see that for this one, x times 1 is x. And we do just kind of quickly get an answer of 21 times cosine 35. And let's switch it up a little. Let's use the other calculator this time. If you have the other calculator, then you can do this problem, no sweat. You literally just type in 21 times cosine 35. And that's it. 17.20 would be the answer. Alright, so what else we got? We got 11, 12, 13, 14, and then we're on to word problems. So okay, I'll do all 4 of these, but I'm going to do them faster and faster as I go, because you should need less and less help. But look in here. Oh no, super psych. I take it back. This is completely different, of course, because in number 10, you knew the angle. You were solving for a side. Number 11 is totally different because you know the 2 sides and you're now solving for an angle. So I better go slow again. Your first approach, though, to solving for an angle is to do the same thing you did before, which is mark the sides. And so 23 is back to being opposite. The 24 is the hypotenuse. So reading this, I can see OH implies that we want a sine equation. But we used to always take the sine of the angle. And our angle is our variable. So I guess x is going in parentheses. And we got to figure out a way to solve for it. Then sine equals opposite over hypotenuse. So that would be 23 over 24. And so the idea here is, well, we have to figure out what angle, when you take the sine of it, gives you 23 over 24. So I would start, if I were you, by figuring out what 23 over 24 even is. and I'm getting 0.9583333. Okay, and then from here the idea is, well, I could go just use my trigonometry chart in reverse. I'm looking for 95833. So let's come over here to the chart and let's hunt through the sine column. So literally just start at the top and scroll down. You're looking for 95, okay, we're way off from 9533, right? Looks like that's going to be over here. And again, let's just drop down till we find it. We've got 88, 89, 99, 95, 9583. Here's 953. No. So yeah, 9583. So we would be between 95 and 96. We would be between, head over to the angle. We must be between a 73 and a 74 degree angle. And again, if you don't have a graphing calculator or a scientific calculator, then the best answer you can give me is to say x equals 73 degrees to 74 degrees. If that's the best you can do, I'm not going to mark you wrong, because clearly you knew what you were doing enough to read your answer off of the grid. But if you do have a scientific or a graphing calculator, then you should know that to actually solve this equation using algebra, what you do is you take the inverse sine of both sides. That's sine with a little -1 on it. And if you take the inverse sine of sine, they cancel each other out. It's just like taking the square root of something that was squared. Okay, so these cancel, and there you get your plain old x. And then you see that what you're doing is the inverse sine of whatever fraction or whatever decimal 23/24 turns into. Although you don't have to make a decimal. I only made a decimal so that we could look for it on our chart. But if you're using a calculator, you could leave this as 23/24 and just hit the buttons and tell me what you get. So if I go back to my calculator, I can do this with you. And we know that we want to do inverse sine. So sine, this is sine, right? Well, right above sine in blue, you see sine with a little -1. That's what you need. So hit the blue second button, then hit sine. Make sure you have a little -1 or you'll get the wrong answer. But I can now type in 23/24. It now knows what that is as an angle, and you do the sine of it, and it tells you 73.40. So that's what x is approximately, 73.40. Okay. Let's do another. In number 12, you're solving for x. We're going to take the exact same approach as before. X is my variable. X is my angle. It's a variable. But I can still see that across from it is 10, so that's opposite. I can see that adjacent to it is 13. So if I'm trying to write an equation about opposites and adjacents, I know I'm going to use tangent. It's the TOA in SOHCAHTOA. But we know that the tangent of x has to equal opposite over adjacent. That's 10/13. That means tangent of x has to equal about, well, I don't know, 10 divided by 13 equals 0.7692. Okay. So again, if I've got a decimal, I'm going to go hunting in my chart. And we're going down the tangent column this time. And I'll just start here. We're looking for 0.7692. So 0.76. So it looks like it would fall between here and here. 7536 and 7813. And so those angles are 37 to 38. So x must be somewhere between 37 and 38. Did I say 37 and 38? Hope I did. Let's check it. Let's check it on the big guy calculator. To check this, we would do inverse tangent of this fraction, 10/13. Yeah, great. I'm getting 37.57. which is definitely right in that window. It's definitely between 37 and 38. All right, that's two more questions down. Let's do 13, 14. For 13, I see the x. I see 30 is opposite from it. I see 39 as the hypotenuse. So I'm setting up a sine equation right away, saying the sine of x equals 30 over 39. Now, if you were paying attention a minute ago, you heard me say that these fractions should always be reduced. But this is the one time you don't really need to reduce them, because if you divide this out to get a decimal, you look it up on your sign chart, you're going to get the same decimal no matter what. So that you don't have to waste time simplifying these, although if you really wanted to, you could divide them both by 3. You could call this 10 over 13, but we'll get the same answer for x whichever way we go. And again, I'm assuming many of us have the fancy calculators, so we would just do the inverse sine of, just do 30 over 39. There's no reason to simplify it. But if you hit those buttons on your calculator, you're going to be just fine. My calculator, of course, is in the way. Move. But, so, how do I do this? You just press the blue button, and you get the function right above sine, called inverse sine. And into that function you type 30 over 39. There you go, 50.28. Okay, and then in 14, we'll approach it the same way. So I see x. I see that I have an adjacent side and a hypotenuse. So that's a cosine equation. We'll say that the cosine of x equals 17 over 18. And we'll say I guess we'll say inverse cosine of 17 over 18 is whatever x would have to be. So if we do this in our calculator, we should be able to do it quickly. So you just do inverse cosine. So hit second cosine to get that inverse cosine, and then just type 17 over 18 into it. And that's it. I'm getting 19.19. All right, I think word problems are up now. Yep. So word problems can be tricky if you have to draw your own picture. But notice for number 15, the picture is already drawn. For number 16, there's no picture. 17 gives you a picture. 18 gives you a picture. Yeah, okay. So what I said in class was, I think every single word problem on our upcoming quiz, you'll have the picture already drawn for you. So you won't really have to worry about drawing the picture incorrectly, but you still have to worry about how to do the math. So if I read this, it says find the angle of elevation to the nearest degree if you're standing 400 feet away and the building is 850 feet tall. So this is the building, obviously. It should be 800 feet tall, and they did label that for you. Then they said you're standing 400 feet away from the base of the building. Well, this is the base of the building, and here's you. So yeah, that's pretty far distance. So 400 feet away, there you go. Then the angle of elevation that they mentioned. Find the angle of elevation, nearest degree, da, 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 da. Yeah, okay. Okay, so the angle of elevation would be the angle formed by basically what you're looking at. So this line that represents your eyesight up to the top of the building, you want that angle in reference to the horizontal flat ground. And basically once you have that, this problem should not feel any different from the last two that we did. We had an angle in two sides, so we labeled it, we came up with which trig function we wanted, we did the inverse, and we got our answer. This is going to be the same. So looking at it, I see that we're working with an opposite side and an adjacent side. That makes this a tangent problem. Alright, so what are we doing? We're going to take the tangent of x. We're going to set it equal to opposite over adjacent, so 850 over 400. Okay, so I think the next step is to actually figure out what the 840 over 400 is. Alright, so as a decimal, that's only 2.1. And usually we like to have 4 decimal places. If you really want to, you can make them all zeros or something. But now we go hunting for that decimal on our trig chart, 2.1. And of course, remember, we're going to be looking through the tangent column, not sine or cosine. But it looks like we're way over here, because this is where these things are getting bigger, bigger, bigger. But what are we looking up? 2.1? So 2.1 would be here, between 2.0 and 2.144. So that means our answer should be the angle that falls between 64 and 55. And again, like I said, that's good enough. So you can tell me x is somewhere between 64 and 65. Although, if your calculator is fancy enough, then we could instead do inverse tangent of 840 over 400. Just type in the original fraction. That ought to do it. Except that doesn't do it. Okay, sorry, I left off a 0. Second entry, boop. Alright, big difference. 64.54 is the answer. Okay, one word problem down. Let's look at the next one. And I'm pretty sure, no, I don't think I did do this one with the class. Maybe I did. But it says there's a ladder leaning against a house and it makes a 30-degree angle with the ground. So it sounds like I need some ground. Then it sounds like I need a house on that ground. And then it sounds like I need a ladder that reaches part way up the house and reaches down to the ground. So this is my ladder. Now it says the ladder forms a 30-degree angle with the ground. That would make that my 30-degree angle. It says the foot of the ladder is 7 feet from the foot of the house. So if this is the foot of the house, we're going 7 feet to the end of this ladder. Then what? Oh, then nothing. Then they want to know how long is the ladder. So the length of the ladder would be this dimension, the actual ladder itself. That would be x. And so the height up the house, this question just isn't about that dimension. There was a different question that asked about the height. That's why I got confused for half a second. But in this problem, we just don't care about that dimension. And it's fine. It's fine because given our 30-degree angle, this guy here is adjacent. This guy up here is the hypotenuse. So we can write ourselves an equation. Adjacent and hypotenuse sounds like cosine to me. So we'll say the cosine of 30 is equal to adjacent over hypotenuse, so 7 over x. This means that when I cross multiply, I'll have x times cosine 30. And that'll equal 7. So to actually solve for x, I'll have to divide by cosine. And I'll get 7 divided by cosine 30. So let's do that. And I'm getting 8.08. Okay, so I see now that my beautiful house was trapped behind the calculator. Turn that off. hopefully you understood what I said. It's hard for me. The calculator doesn't actually show up on my screen. It just shows up in the video. So it's a little hard for me to know when the calculator is blocking. I'm apologizing for that. But all the work is over here. Hopefully you guys understand the work, especially now that you can see the picture more clearly. But an answer of 8.08, that makes sense to me. It sounds good. The only thing I'm missing is, we did say it was, well, not that foot. That's not the right foot. This one, 7 feet. So this is supposed to be feet. Make sure you actually give me the units and say feet. Okay, but that's 16, 17, 18, 19, 20. All right, I'm gonna just keep pushing to finish this off. I was gonna break this down into more parts, but let's just get this thing over with. So looking at 17, I think I explained to most classes, but not necessarily all. But there's a problem here because they're talking about the ramp being 16 feet, and then they talk about the vertical rise being 14 inches. In a math problem like this, you really can't have two different units. If you have feet and inches, then you either need to turn the inches into feet or the feet into inches. And turning inches into feet is not easy because 1 foot is 12 inches, right? So sure, 14 inches would be 1 foot, but you would still have 2 inches left over. And so if you tried to express this as feet, you'd get some fraction of a foot left over, and not a clean fraction either. You'd get 1 foot and 2 inches out of 12 feet. 2 out of 12 is a sixth. So I don't think you want to be messing around with 1 and 1/6 as your number of inches, or as your number of feet. So it's going to be much easier to turn feet into inches because you know that every foot is 12 inches. So if you have 16 feet, then just multiply by 12 to turn that into a whole bunch of inches. And again, we can use our calculator to figure out what 16 times 12 is. Yoink. So 16 times 12 is 192. So keeping that in mind when you label your diagram, we'll say, all right, the length of the fence isn't, or the length of the ramp isn't going to be 16 feet. We're going to use 192 inches instead. And that's because the vertical rise over here is 14 inches. So I now have everything expressed in terms of inches. And what we're supposed to solve for is the angle formed, angle x, the angle formed by the ramp and the ground. Because the whole point of the question is we want that angle to be less than 4.78. If it's not less than 4.78, then it doesn't meet the code, the specified uniform federal accessibility standards, and so you'd have to rebuild it if it's too steep. So to do the math, I would of course find my sides. I have the opposite side and I have the hypotenuse. So OH means sine, and we know that the sine of our angle, angle x, is equal to 14 over 192. And that means that the sine of x has to be, well, whatever 14 over 192 is. Let's find out. I think I did that wrong. 14 divided by 192. 0.0729. All right, if you don't have a graphing calculator, then the best you can do is go over your Trig chart and go hunting for 0.0792. It's probably going to be over here in the small numbers, which are blocked by the calculator right now, so we'll turn that off. 0.0729. Oops, I turned the other one on. Alright, so we're looking for 0.7, right? Well, 0.7 would fall here, between 4 and 5. So that's kind of not good enough of an answer, but we'll write it down anyway. We'll say we know that x is somewhere between 4 and 5. But remember, we were supposed to compare that number to 4.78. If all I know is that it's 4-ish, then I can't really decide if I'm bigger than this number or less than this number. So maybe for this problem, you really need to use a calculator. There won't be a problem like this on the quiz. You guys will be able to always just give me a couple of values. But just for curiosity's sake, let's see what the more exact answer is. There we go. I'm moving the wrong thing. Put that over there. Alright, so we want inverse sine of 14 over 192, I guess. Alright, what do we get? 4.18. So that's quite small. So notice the code again was 4.78. We're definitely below that. And since we're less than that, we do meet the code, the accessibility standards. So we can say, I don't know, ramp does meet standard. Okay, that's 17. 18's about a hot air balloon, I guess. So in the building problem a minute ago, we had these angles of elevation, right? The ones that rotated up from the ground. In the hot air balloon, we get kind of the alternate version of that. If someone's up here in a hot air balloon and they're looking down at a person, then that's called an angle of depression. Anything that sort of rotates down is an angle of depression. And if I keep reading, it says you're in a hot air balloon that's 600 feet above the ground. So there you go, 600 feet already labeled for you. It says if the angle from your line of sight to your friend is 20, then how far to the nearest tenth of a foot is he from the point on the ground below the hot air balloon? So they're asking for the distance along the ground to your friend. So how'd you do this? Well, the big thing to remember is these angles of depression are always equal to this corresponding angle of elevation. Now I shouldn't say corresponding, I guess, because they're not corresponding angles, they're alternate interiors. The same alternate interiors that we've used before. So knowing that this outer angle was 20 means I can find this inner angle, which means I now have an angle that I can use to try to solve. So I've got the 20 and I've got the 600, so this would be opposite, this would be adjacent. So I can write a tangent rule. Yeah, sure. Alright, so the opposite would be 600, the adjacent is x. So we just have to solve this. Throw that over 1, you get x times the tangent of 20. But you're just going to divide by tangent 20 again. So the tangent 20 would fall off of the x and you would get 600 divided by tan 20. And I'm going to use the easy way to do this again. So let's just do 600 divided by tan 20. So I'm getting 1648.49. But again, I only want you to round to 2 decimal places. And so this 4 is not high enough to bump this guy up. Even though the 9 would round this 4 to a 5, you don't do that. You only look at the very next number. And since 4 is less than 5, we just leave this guy alone. Don't mark it wrong. Leave it alone. It's correct. Okay. 19. All right, a couple more. For 19, it says you're flying a kite. You've let out 80 meters of string. So here's the ground. There's a kite. And it says I've laid out 80 meters of string. So that's my 80 meters. it says the angle of elevation up to the kite from the ground, that would be this angle, is 40 degrees. And then it says if the string is stretched nice and straight, then how high is the kite above the ground? So we're looking for this straight up and down distance representing the height of the kite. So to do this, again, you just mark your sides. This is opposite and this is hypotenuse. So that sounds like sine to me in SOHCAHTOA. So we know that the sine of angle 40 equals h over 80. And you just cross multiply. So you get 80 times the sine of 40. And what does that give us? Well, use your calculator and find out. I'll use the stinky one again this time, in case anyone forgot how. Alright, so for this, I wouldn't type the 80 first. I wouldn't type sine first. We need to actually type in 40 first. We want to get the sine of 40 and then multiply by 80. So go 40, then take the sine of it, and then multiply that by 80. That's what I'm getting, 51.42. Okay, and it says here this is 80 meters, so this must also be meters. And then we just have 20 left. So for 20, they want you to solve the triangle. Solving the triangle means finding all the missing parts. So that means, well, we already knew C. They gave us 90, right? And we already know AC. They didn't write it in for us, but we know that they gave us 29.3. And they gave us angle A too as 28. So when you're solving a triangle, you already have half of the whole triangle. So the only thing left to do is find whatever's missing. And finding the third angle is a piece of cake because we know that all three angles add up to 180. So just show me a little bit of work. Say the measure of angle B equals 180 minus the 28 that they already gave us minus the 90 that they already gave us. And that would leave behind 62. Yeah, so 62 degrees. Okay. All right, now, how do I find the sides? Well, if you want to find AB, I don't know. I would call this X, I guess. We'll find BC, then we'll find AB. AB is going to be our hypotenuse. It's going to be Y. So how do I do this? Well, I've got the 62 degree angle. I could choose to use that if I wanted, but I'm going to stay focused on the 28 that they gave me, because using the 28, X over here will be opposite, and this number here will be the hypotenuse, and this number will be the adjacent. Oh, nope, 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 nope. Sorry, the hypotenuse is always across from the right angle, of course. So this number down here, the Y, that's our hypotenuse. So this number up here is adjacent. Alright, so let's say you were solving for X. Then you'd be using the opposite, and the only side you know is this, so you'd have to use adjacent. And opposite over adjacent means tangent. So you could write an equation where the tangent of 28 was equal to X over 29.3. So what do we do? Just cross multiply, yeah? And X will be whatever 29.3 times tangent of 28 is. And I would do that on a calculator. I'm going to use the other one. Yeah, that one. Okay. So again, just type in what you need. 29.3 times tangent 28. And that's it. 15.58 it looks like to me. Okay, so that's x, which is BC. We'll put that down there. 15.58. All right. So just one side left to solve for. It's AB. Now AB is the hypotenuse, and we're going to find it using adjacent. So that sounds like cosine to me, adjacent over hypotenuse. We're using the 28-degree angle. The adjacent side is 29.3. And the denominator is y. We're solving for y. So again, if you cross multiply, you'll get y times the cosine of 28. Which kind of feels weird, I guess, but then you multiply by 1, you get 29.3. So the only thing left to do is divide by cosine 28. 29.3 divided by cosine 28. All right, let me try doing this one with the chart again, just for fun. So cosine 28 on the chart, you got to find that 28-degree angle. It's right there. And we want the cosine of it, only the cosine. So I'm seeing 0.8829. So that means do 29.3 divided by 0.8829. So how do I do that? Yeah, good. Okay. Let me bring up the other calculator, put the other one away. My face got in the way, didn't it? How's that? That's better. All right, calculator. So we're doing 29.3 divided by 0.8829. Okay, 33.19. Hopefully that's what you got too. Oh, let me put that in the box, I guess, so we have a full box. So y is AB, so 33.19. And then the 15.58 went in here too. Down here, right? I don't know. Everything got messed up when I moved it, but that's okay. But that's it. That's the end of your review packet, I think. Yeah, okay. So if you still wanted more practice, don't forget that you can always do the delta math. That thing is all set up. I haven't checked yet if anyone went in there to do any practice problems, but I'm sure some people did, and you should too, because the more practice you get, the better you'll do. So good luck, and I'll see you on Monday.